yesterday we did adding and subtracting fractions with like terms. What that means is if you had a pizza eating contest with your brother or your sister, okay? I don't recommend binge eating, okay? That's a lot of unnecessary calories. But if you were having a competition with someone over how many pieces of pizza you ate, and one person was like, yeah, I had 5 pieces of pizza. And they're like, oh yeah? Well, I had 15 pieces of pizza. Now, the only way that those two could actually be compared is if you had the same size pieces, right? So if I had a pizza that was... Come on. Over here. Come on. If I had a pizza and I cut it into 8 pieces, which is common, if somebody said, I had 5 pieces of pizza, and they ate this much of the pizza, okay, that's a pretty good size, pretty good amount of pizza. But then someone's like, oh yeah, well I had 15 pieces of pizza, and this is what their pizza looked like. They had 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Darn it. That didn't work as well as I wanted it to. I was trying to do it too quick.
Looks like that guy lied.
There. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? The person on the right did, in fact, eat more pizza, right? Yeah. But not that much more, right? You need to have the same denominator, because this one here, he ate 5/8 of the pizza, and this guy here ate, or this person here, ate 15/16 of the pizza. Now, if we weren't looking at a pie graph, we wouldn't be able to tell who actually made more pizza too easily, or how we would compare those. We need to have common denominators, and this is what you guys had last year. Okay? You guys had last year, however, this year we're going to be using a little bit bigger numbers. So the only way that you could really compare it would be is if you guys, oh, it's pretty, if you guys had the same denominator, like we did yesterday. Today we have to create the same denominator. So without any further... Is that everything? I don't think so. Not any further ado? Draw. Notes. To add fractions with unlike denominators, unlike means they're not the same, first you must find the common denominator. You must find the common denominator. You must find the common denominator. Now, there are 3 ways that you can find the least common multiple of a number. So this is a review. This goes back to September 8th, the lesson that we had then. There are 3 ways that you can find it. The first one, does anybody remember? Finding the least common multiple. Tamaya? Ladder method, upside down division. Okay, listing multiples. Oh, she's on a roll. Yes. Prime factorization, beautiful. Ladder method, listing multiples, and prime factorization. My goodness, it is warm in here. I don't know if my AC is... It is. It makes me nervous. When you find the When you find the least common denominator of 2 or more fractions, you're really finding the least common multiple. You actually find the least common multiple of the denominators. So, more review of what we had on the test from last week. Finding the least common denominator. So we're going to find the least common multiple of those two numbers. And I'm going to do the prime factorization method because that's the one that the least amount of people used on the test. So I want to remind you how to do that. We have 10. We have 16. 4, 4, 2, 2, 2, 2. 10 is just 2 and 5. So with the prime factorization, what I'm going to do is I'm going to say this is the list of them. I have 2, I have 5. I have 2 times 2 times 2 times 2, which is equal to 2 to the 4th. And in the prime factorization method of finding the least common multiple, we're going to take the highest powers of each of these numbers. So this is 2 to the 1st, that's 5 to the 1st, and multiply them together. So I have 2 to the 4th times 5 to the 1st, which is going to be 16 times 5, which is 80. If you would have done just multiplying together, that is a multiple of both, but it's not the least common multiple. So that's 80. Yes, sir. This way is the way that was used least. I just wanted to keep that a little bit in your memory. So we'll do it under upside down ladder. So we'll do the ladder next. Yes.
Wait, why didn't we do like what if this?
Sorry, say that again.
Like so, like you know how it was like 2 times 5 or 10? How come we didn't like add it?
Because the method that you have to use whenever you're doing the prime factorization, and this is the notes from 2. Let's see, what day was that? Oh, there it was. This was section 4-7. It says to take the, let's see here. Is this when we introduced it? Yeah. It says then multiply the largest powers of each base. So we ignore the ones that have the lower powers. Now, what did we just... Okay, we found that it was 80, so write 80 in there. So we write 80 as being the common denominator that's the best, the biggest. What did we multiply 16 by in order to get 80? What did we multiply it by? Emmy? 4. And in order to keep this true, we also have to multiply the numerator by that same number. So we have to multiply the numerator by 4. And the way that we multiply fractions from what we've done last year is you just multiply straight across. Then we had to do the same thing here, but it's not going to be 4 there because 4 times 10 would be 40. Haley?
8.
It's 8. So I have to multiply the numerator by 8 as well. And through the 5, 6, 7, 8 trick, that's how we have it. Hopwood?
Wouldn't it be 5 times 16 equals 8?
You're right. Thank you. 5. I did that same thing last period. And if you're ever unsure, you would just do. You can do 16 divided by 80. Doesn't go in anything, but then you could just try the multiplication. Because if you did 4, it would be just a little short. So you know there'd be 16 more than that would be 5. So that's review. And I think I can feel the air conditioning kicking on now as I feel sweat. So it introduced, it said, in order to make, or we can, salud, we cannot add or subtract fractions without like terms. So we have to create like terms by finding the least common multiple in the denominator, which would be the least common denominator. Just as a reminder, a lot of times people are putting least common denominator as being the greatest common factor. Have I talked about the let's see here. Have I talked about this before? Okay. Now, the greatest common factor is like being the biggest gymnast on the national team. Okay? Gymnasts are typically really small, right? Okay? Really small and really muscular. So it is the greatest common factor. Because remember, factors are prime and they're tiny, right? They're small. But then we have the least common multiple. That's like comparing a national team gymnast compared to the smallest lineman on the Rams. Okay? Because it's multiple. This M here stands for multiple. So it gets bigger. Because when you multiply things together, it gets bigger. When you factor things, they get smaller. Okay, this is the number. There. Perfect. Okay? Does that help anybody out a little bit? Because you see the word least and you think small, right? But don't forget that the M in that stands for multiple. Okay. So we need to find the least common multiple between these two. In the way we did it up above, we are going to do it a different way now. Now we're going to do the listing multiples method. So I have multiples of 9, multiples of 12. To save myself time, which one should I do first? Who remembers that from the notes? Raise your hand. Jesse, do you remember which one we should do first to save time? The bigger one. Because wouldn't you reach it faster? That one's not really fair for me to ask you that because 12 and 9 are pretty close together. But if it would have been 24, then you'd want to use like 24. So I'm going to go 12, 24, 36. Ding, 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 ding. I already know that 36 is a multiple of 9, right? Yep, it's going to be by 4. So I'm going to do 36 in the denominator. 36 plus something 36. Excuse me. Excuse me. Now, what am I multiplying? What am I multiplying 9 by to get it to turn into this? Kobe? 4. So I have to do the same thing to the numerator as well. And 7 times 4 is 28. What am I doing to 12 to get to 36? Tamaya? Times 3. 33. I have common denominators, so now it's just like last night's homework. So I have 50 plus 11, 61, 36. Am I done? No. I need to simplify. That cannot be reduced before I simplify. So I have to do, if you can see it, that's great, but you could also do this. You do 61 minus 36. So I have 1 and 25 36ths. And there's nothing that goes into both of those numbers equals m. And then, or any questions on that? Yeah, Peyton.
I have like a tiny, it's not, it's still like, just what we're doing. But if you have like 6 over 5, wouldn't you see like how many times 5 goes into 6? And then like it'd be 1 over 1.
Are you talking about the 20, or?
Yeah.
Because on here, I'm. Can you describe? Because you're looking at the same thing I am, but.
No, it's on this one.
Oh, on the homework from last night. Okay. Let me see. What are you talking about?
If it was like, since you got 6 over 5, did you see how many times 5 gives you 6?
Yep. Yep. So I just did the subtraction because I'm imagining that you guys might be able to recognize how close it is. Imagine how close it is, but this is what you're doing with that, Peyton. Yeah. I'll clarify that because you weren't here for the lesson yesterday. What you're doing is you're doing 36 divided by 61. Okay, it goes into that one time, 36, and here's that 25 that I just came up with. So it's remainder 25. All right? Any questions on that one? No? Now with this one here, whenever we have addition, what did the notes say to do with the whole numbers? What did the notes say? Kennedy, you want it? What did it say about it? Okay, I saw that. Adam, person who wasn't here. You have to add them? Yes, that's true. Yeah. Yep, you're gonna add them together in front because you can do this with addition. You can do this with addition. With subtraction, I want you guys to always make it an improper fraction, please. So we have 4 plus 7 plus 1 6 plus 11 18ths. Now I know that whenever you have a very low number that can be multiplied to get to the next one, those are the ones that are usually quicker. Chase, what do you see?
I see that 1 6 will turn into 3 over 18.
But how are you doing that? There we go, yes. So we are multiplying both of them by 3. I have to take my 4 and my 7 with me, but 4 plus 7 is 11. Ew. Stop it. 4 plus 7 is 11. I'm doing what this here is happening. 1 times 3 is 3. 6 times 3 is 18. 11 over 18. So now I have 11 plus 14 18ths. I don't need that plus in there. 11 and 14 18ths equals n. Am I done? No, why not, Ian?
Because we can divide 14 and 18 by 2.
Good. We can reduce that by 2. So it's going to be 11 over 7 ninths. I'm going to circle those. Make sure we reduce. Make sure we reduce. Sarah, can you work on your homework at home or out of class? I want to make sure that you understand all this, okay? Sarah, okay? I want to make sure you understand all this. I appreciate the effort to get that done. Okay. This one we have subtraction. We need to find the least common multiple of 4 and 3 to find the least common denominator. And those are two really small numbers, so you can test it out and see if you can just multiply them together, right? Peyton, what are your thoughts?
12.
Okay, it is 12. So I'm going to rewrite this because of how small that is. Is it changing font size on here? Or typeface size?
Yeah.
Okay. I want to make it a different color so I can see better. So in order to get this to be 12, I'm multiplying 4 times 3, and I have to multiply the numerator times 3. This one's being multiplied by 4, so this one has to be multiplied by 4 to keep it true. Now I have 8 minus, I have 3 minus 8. I have 3 minus 8. I'm going to be in the negatives, exactly. So it's going to be negative 5 12ths. Can that be reduced? No, it cannot. Oops, sorry. Here's another situation where we have one of the numerators or one of the denominators that is the LCD. Okay, least common denominator. So we have 7 and 21. Right away, you should be able to tell that the denominator is going to be 21. And if you don't, that's okay, as long as you get it anyway, eventually. I'm going to be multiplying 7 times, ooh, that's too thick. 7 times 3, as I just heard whispered, which is going to be 6 times 3 as well. So it's 18. That one's already there. Comes out to be 23 over 21. Am I done?
No.
Why not? Can you tell me what that number is? What type of number it is?
It's an improper fraction.
Beautiful. It's an improper fraction. I need to make it proper. Okay? Inviting him over for dinner, so I want to make my buddy proper. So we have 1 and 2 21sts is equal to y. Ian, can you open that window and see if there's any airflow that you can feel? Just one. I want to see if there's any airflow, because if it's going to introduce cooler air than what we have in here, then we're going to have it open. If not, it's going to be counterproductive. Hold on. How about now? Not significant. Okay. Did we do all these yet? Yes, we did. Evaluate each expression. Now, evaluate, if you remember, means you just plug in what the variables are. Okay? You're plugging in what the variables are. So the variables in these, for A is 4/9, B is 2/3, and C is 3 7/18. So I'm going to plug this one in here. So it comes out to be A is 4/9 plus C, which is 3 7/18. As we learned yesterday, the first thing I'm going to do is I'm going to pull that whole number out front because it's addition and I can do that. Then I have something very close to one another for 4/9 and 7/18. You know that 9 times 2 is 18. So what are you going to have to do to that 4? Chase, what am I going to do? I'm going to multiply it by 2. So it comes out to be 3 plus 8 over 18 plus 7 over 18. Combining those, I have 3 and 15/18. Am I done? They have a common factor of 3, which means I need to divide that fraction by 3. So now I have 3 and 5/6. Three and 5/6. Now we have B minus A. It's subtraction. B equals it's 2/3 minus A, which is like we just used last time. Where am I? There we are. 4/9. What's going to be the least common denominator just by glancing at it possibly? What do you notice, Cole? 9. It's going to be 9 because just the 3 multiplied by 3 is going to be a common denominator of 9. So I have now 6 over 9 minus 4 over 9. And I have common denominators, which means I just do the 6 minus 4. So I have 2 9s. I'm going to move that down. Wouldn't that be nice? Let's do this one. Pink is okay. We have C plus A minus B. I'm going to rewrite it first so I don't make any silly mistakes. I have 3 7/18 plus A, which is 4 9ths, minus B, which is 2/3. Isn't it? Yep. Yep, number 8. I'm just going, we're kind of doing a different way of going through this because of the navigation with Microsoft OneNote. So I noticed that these guys are going to have a very similar situation going. Luckily, they're all factors, or all multiples of 3, right? So that means that if they're all multiples of the smallest number, we can just use biggest number if it were 2, and it's even a multiple of the second number. So that means I'm going to pull this 3 out. If this was a subtraction symbol, I wouldn't be able to pull that whole number out. In general, whenever you see a subtraction symbol, I want you to make it an improper fraction first. Yeah. So we have 3 plus 7/18 plus something over 18 minus something over 18. What do I need to do to 9 to get it to be 18? Haley? Multiply it by 2. I need to do the same thing here. To get 3 into 18, I have to multiply by 6. So it means I have to multiply 2 by 6. Taking multiple steps, we have 3 plus 7 plus 8 is 15 over 18 minus 12/18. We still have common denominators. Yes. So I'm going to go up here. That's a beautiful arrow. See how good that arrow is? Thank you. Now I have 3 plus 15 plus 12 is 27. And we still have 18ths. Am I done? No. Okay, how about now? Am I done now? Oh. What do I need to do? Okay, good. I added. So 15 minus 12 is 3. There. Ha ha ha. Now we got it, right? Simplify. These two have a common factor of 3. So I have to go 3 1/6. 3 1/6. A plus B plus C. We found that the common denominator was 18 already, didn't we? Yes. Okay. So since we had A, B, and C already found with the common denominator, I'm just going to rewrite those from the one before it for time reasons, because I'm still showing my work. 3 plus 8 over 18 plus 12 over 18 plus 7 over 18. 7. Yep, okay. And that's just taking the ones from the one before it. So we have 3 is 27 over 18. 3 and 27 over 18. I need to simplify this and not sneeze in the mic. I was able to mute before I sneezed. Ouch. This is going to come out to be 4 and 9/18, which comes out to be 4.5. I think I just heard someone say how, because this here is the same as doing 3 plus 1 and 9/18. Because 27/18 simplifies to 1 and 9/18. Then 1.5. Okay, the distributive property time. This is the one where your eyes glazed over yesterday, and hopefully it won't glaze over today, because hopefully you guys did well on the last little bit of the homework last night. Since they share a common multiple here that we don't know what it is, it's called a variable, I'm going to pull that out, and I know I can because of the distributive property. And that D is going to be on the outside of those parentheses until we're done with the inside of the parentheses. So I'm going to, do I need to make this into an improper fraction? No, because there's no subtraction there. So I'm good with taking the whole numbers. Then I have 1/5 plus 5/6. I want to find the least common multiple of 5 and 6. Okay, there isn't one that I can pull out of both of them, so it's just going to be the two of them multiplied together. That was the upside down ladder method. So it's going to be 30. So I have D still hanging out on the outside. 4 plus something over 30 plus something over 30. What am I multiplying 1 by to get, or what am I multiplying 5 by to get 30? Chase? 6. And I'm multiplying 6 by 5 to get 30. So now I have D equals 4 plus 11/30. 4 and 11/30 times D, which is just 4 and 11/30 D. Ew. I forget how to draw D's when I'm doing it online. There. There. I pulled out the common factor. Yes, ma'am. Oh. 6 times 5. That's not right. I did something wrong here. Oh, that's it. That's it. You are correct. Thank you so much. Thank you so much. This is 25. I just saw that I was doing something wrong. That's 31. This should be... Yeah. There we go. Thank you. Good catch. Okay, last one with... Whoa, okay, sorry. Oh. Well, it might help if the air conditioning was on. Can you close that window? Looks like one of the 8th graders turned it off. Number 10. Look, I have common variables in each one, so that means I'm going to use the distributive property. Get that thing out of here. I'm going to take all the whole numbers and add them together first. Then I'm going to take the fractions and add those together. They do not have common denominators, which means that I have to make common denominators. I'm going to find 7, 4, and 14. Okay, those don't have any common factors, and I can't just multiply them all together. So I'm going to do the list method, starting with 14, 28. Oh, ding, ding, ding. So I have 20 right here. 20 plus something over 24 plus something over 28. What am I multiplying 4 by? Ooh, too thick. What am I multiplying 4 by to get 28? 7. So I need to multiply 3 by 7 as well. 3 times 7 is 21. I'm multiplying 14 by 2, so I need to multiply 1 by 2. I'm multiplying 7 times 4, which means I have to multiply 6 times 4. Yay, common denominators. I'm just getting all sorts of colorful now. So my x is still hanging out on the outside. I told her to leave, but she wouldn't. So I have to add these together. Almost looks like an odd symbol. So I have 21 plus 24, which is 45, plus 2, which is 47. 47 28ths. Forty-seven 28ths. Oof. Pushing for time. That is going to come out to be 21 and 19 28ths. Which comes out to be 21 and 19 28ths. X. This one here, since we have 2, 8, 8, and 4, the least common multiple of those 4 are 8. So you would do 8 and add those up. Smith that. Mm-hmm.